Hi class, we're getting into lesson 2's extension. So an extension is just getting deeper into the lesson. So we're still talking about expressions, but we're going to talk about factoring those expressions and what factoring means. So when factoring an expression, you write the expression as a product of factors. Think about what factors are. If I ask you for the factors of a number, what are you telling me? So I'm going to tell you right now. Factors, a lot of us get confused with factors and multiples. So like if I ask for the number 10, what are the factors of 10? You would have to tell me which numbers do I multiply together to get 10. So factors are what you multiply together to get that number. Whereas multiples are when you're making the number bigger, like 10, 20, 30, 40. When you multiply that number by another number, it gets bigger. But factors are when you kind of break down that number. Like I know 5 and 2 give me 10 if I were to multiply them. Another pair of factors for 10 are 1 and 10. Those are factors of 10. So we can use the distributive property to factor expressions. And I'm going to tell you what I mean by that in just a minute. But factoring is kind of when we're breaking apart the expression. So let's look at example 1 here, and we're going to do this together. We want to factor 24x minus 18 using the greatest common factor, so the GCF. So first what we have to do is find the greatest common factor between these numbers. So when we're factoring an expression, you're really focusing on what numbers are within that expression. You can kind of ignore the variable at first. So if I have the numbers 24 and 18, I want to know what their greatest common factor is. They might have a few common factors, but which is their greatest? So you might want to start, and I would suggest, by just listing the factors of each number. So I have the number 24. Let's list out all the factor pairs of 24. I know that 1 and 24 equal 24. 2 and 12. What else? 3 and 8. And then it should be 4 and 6, which I'm running out of room here. So go ahead and write those factors down. And then let's write the factors of 18. I know it's 1 and 18. Go ahead, maybe list out the rest. Should be saying 2 and 9. And then 3 and 6. And that's it. So now what you want to do is you want to look, what's their greatest common factor? So see how they have 1 in common, but that's not the largest number they have in common. They also have 2 in common, 3. But what's the largest one that they have in common? I would say 6. So the GCF here is 6. So I'm going to write GCF equals 6. So the first step would be to find that GCF. Now we need to set up the form and pull the GCF out. So what that means is when I say pull it out, we're dividing it out of these terms to figure out what's left. So set up the form. What do I mean by that? Well, when we're factoring an expression, it's always going to look the same. You're going to have a number on the outside. In this case, it's going to be our GCF. And then whatever's left, you're going to put inside of parentheses. So the left expressions or whatever parts are left. So we're going to kind of set that up. So some of us this may be familiar. we call it the upside down cake method. You don't even have to use this method. It's just a way that I'm going to help set it up for us. But what I would do is I would write my original expression. And what I'm doing is I'm dividing out, I'm taking out the GCF, which is 6. So we're pulling out that GCF. Now we're going to find what is left inside after that GCF is factored out or divided out. So another word for factoring out something is dividing it out. So if I divide 6 out here, I want to know what is left. So again, upside down cake method, you kind of add like a layer of cake. It's like an upside down cake. And we're actually going to do that division. If I divide 24 by 6, what do I get? Should be thinking 4. Bring your variable down, bring your sign down. And now what if I divide 6 out of 18? What am I left with? 3. So find what's left inside. So this should be what's left inside after you divide the 6 out. 6 is on the outside, so we're going to make this look like we're in factored form. It should be 6 parentheses and then what is left. Remember, I told you what's left when you divide out, you put inside parentheses. So this entire expression is your answer. What does that remind you of? What does it look like to you? To me, it looks like the distributive property. If you want to check your final answer, you could distribute and see if you get what we started with. So to check, you write your answer. And the goal when you distribute is to get what we started with, which was 24x. And you might want to write this at the bottom. So now let's see if we get that. Let's distribute 6 in. What's 6 times 4? We get 24x. 6 times 3, we get 18. Did I get my original? Yeah, so I know that I'm correct. This is your answer. That is factoring an expression. So factoring can get tricky. It can either ask to use the greatest common factor like it did here, or it can tell you exactly what it wants you to factor out. Remember, factoring out means we're dividing it out. Let's look at this example here. So factor 1/2 out of 1/2 x plus 3/2. We're dividing it out of this expression. So you might want to rewrite it, or I'm just going to kind of show we're going to start that upside down cake method. If it wants me to factor 1/2 out, I'm going to kind of show like I'm dividing out a half. I'm going to add my next cake layer. And we're going to put what is left when I divide 1/2 out. If I divide a half by a half, I just get 1. When you divide a number by itself, it's just 1. In this case, x. You always bring your variable with it. Did I need to put that 1 in front of that x? What do you guys think? No, you don't. You don't have to have a 1 there. You could just have it as x. If you put the 1 there, totally fine. Now we're going to carry your sign or operation down. And then we're going to divide 3/2 by a half to see what would be that term left. Now this is where I said it gets kind of tricky. We can't just mentally do that like we've been able to. So you're going to want to write off to the side to show your work. You always write the number that's in your original expression first, divided by what you're factoring out. And that's very important. The order does matter. So now what we're going to do is we're going to do this division. How do we divide with fractions? This was back in chapter 2. Hopefully we remember. Keep, change, flip. So let's do that. We're going to keep 3/2, change division to multiplication, and flip 1/2 to 2/1. You can either multiply straight across and then simplify, or if you like to cross simplify first, go for it. But once you do that, you should get 3/1, or just, that's the same as the number 3. So now that's the other part of my expression. So now this is what's left when we're thinking of factored form. Remember, you want your number on the outside, whatever we're factoring out, and then we put whatever is left inside our parentheses. So let's fill that in. You didn't have to write that. So what were we factoring out? 1/2. So that should be on the outside of your parentheses. That's what we divided out. And then what was left? What's in that bottom layer of your cake? 1x plus 3, or again, you don't need that 1, so maybe just x plus 3. You should have your parentheses. Now that is your answer. That's it. If you wanted to check yourself, you could go through and distribute and then see if you get back to the original. If you do, then you know you're good to go and you're right. Now, if you want to, you can pause the video and try this next example on your own and press play when you're ready. If you don't feel confident or comfortable enough just yet, go ahead and let's just keep watching. I will walk us through this. So for this one, it wants us to factor -2 out of -4p plus 10. So I'm going to rewrite our expression that we have currently. And I want to divide out a -2. So I'm kind of just setting it up, showing that I'm going to take out a -2. Let me set up my next cake layer. And let's see what we get. Now this one's tricky. I have a negative. We haven't done this yet where we're taking a negative out. So we have to pay attention to our signs and our rules here. So if I have a -4 divided by a -2, that should give us a positive 2p. This is where it gets tricky again. I have a positive 10 and a -2. So what does a positive 10 divided by a -2 give you? Different signs. It should be a -5. So we factored out -2. Now let's just set up our final answer. -2 is on the outside. That's what we factored. And what was left was 2p minus 5. That's your answer. Again, maybe check yourself. So distribute -2. What's -2 times +2? That's -4p. What is -2 times a -5? That's a +10. Did I get my original expression? So I know that I'm good to go. However, remember, this is still this is your final answer. All right. I know this is a bit tricky. Factoring tends to be one of the trickier lessons of this entire chapter. We'll do lots of practice with this. We'll take our time. If you don't love the upside down cake method, I'm not pressing you to do it that way. I just think it's a nice way to set it up. If you need a way to set it up, just try it out. We're going to work through this. Let us know if you have any questions.